Good morning, everyone. Okay, so as you all know, Ms. Sajide has to go back to her home country, okay, due to some issues with her family. So I think Mr. Rizal already told me that, and Mr. I'm here to replace her actually, right? So for those under Ms. Sajide's group, tutorial group, okay, so I'll be taking over from today onwards. Right? But I'm not sure about the arrangement for the second assignment, whether it's still going to be in the same group or Mr. Riza is going to reshuffle the groups. So that one is up to Mr. Riza. Right. Okay, so I think I'm just going to start the lecture now, right? So for the meantime, at the same time, probably you can still ask your friends to join the lecture, right? Okay, so I was informed by Mr. Rizal, this week is going to be the last tutorial, to check progress for assignment 1, right? And I was also informed that in the first assignment that you are doing you need to study. I believe you have done some case study on the mechanical transportation system on the particular building that you are studying. Okay. So I hope today's lecture is going to reinforce maybe the knowledge and understanding of the mechanical transportation system. Actually, it's always good to learn first, then you look at the the real object itself, right? So you learn the theory in class, and then you go visit the building, and then you look at the real thing. Right? But it's okay. It's like the reverse process. So you look at the system first in the case study, right? Then only you learn about the theories. I'm not sure whether my connection is okay or not. But if let's say you cannot hear me, right? If you want me to repeat anything, then you just stop me anytime. Okay, so I'll try to repeat again. All right. Mr. Rizal, can we start now?
Sure.
All right. Okay, so now I'm going to share my screen, my slides. Okay, can you see my slides? Can you see the slides? Is that can?
Yes. I can see your slide.
Okay. Dengar tak cakap?
Yeah, dengar.
All right. Okay. So today's topic is about mechanical transportation system. I'm sorry about the codes. That one is the old codes, BLD 60903. So I think now the code is different, but the content is more or less the same. Okay. Right. So mechanical transportation systems. So as you know, and as you have seen in your case study building, right? I'm not sure whether you have seen how many different types of mechanical transportation system in your case study, right? But for today, basically, we are going to cover about three systems, three of the most basic mechanical transportation system in a building. Okay, so as you know, the mechanical transportation system is an integral part of modern buildings used to move goods and people vertically or horizontally, right? So I think most probably you have in your case study, definitely there will be a lift, right, which is to move people vertically, but not sure whether it has escalators or travelators. Sometimes we call it travelators, sometimes we call it moving walkways. Right? The one that normally you would see when you go to like Tesco, Giant, that kind of things, right? Okay, so today we are going to cover about three different mechanical transportation system. The first one is a lift or elevator. Like sometimes we call it lift, sometimes we call it elevator, escalator, and travelators, or like I said, the other name for it is moving walkways. Okay, so let's look at lift or elevators. Okay, so as you know, this is the most common transportation system in a building. Right? So I think even in Dallas also you can see a lot of lifts. So every block has at least I think in block A got 2 lifts. Okay, B, C, D, and E got B. I'm not sure. B I think probably just one. Block C got 3. Okay, D and E also got 3 lifts or elevators. Okay, so it's a very common transportation system, right? So if you look at the one the image below, okay, do you know? I think you know that it is a lift lah. Definitely, it's a lift. But do you know what is it called? That kind of lift is called. Okay, so basically that kind of lift is called a bubble lift, right? So so it has glass walls so that people can see the surrounding, right? And normally it's used in shopping malls. Shopping malls, when you have like a huge atrium, right? It's a huge area in the middle of the shopping malls, right? Or we call it atrium. So you want people to have a view from inside of the lift, okay, looking down to the atrium, and then you can use this bubble lift. Okay, so I would say it is kind of a nice feature to have in your design as well. So in the future, when you have to design like malls, or maybe when you get into masters, right? So you have to do, or you have to design multi-story buildings, high-rise building. So perhaps maybe you can just introduce this kind of lifts as one of the feature in your building. All right, so the definition of a lift or elevator is basically an apparatus or machines, right, for raising and lowering people or things to different floor of buildings. So I think everyone knows that, right? So the function of lifts, so basically is to move people and also goods or services from different level, from one level to another level. Okay, so it's as simple as that. Okay, it shall be provided for non-residential building which exceeds 4 stories above or below main entrance. Okay, this is based on bylaw 124 of UBBL 1984. Right. So it means that if let's say your building is just 3-story, then no need to provide a lift, okay. Even if it's 4-story, right? No need to provide a lift. But if it exceeds 4-story, whether exceeding means whether it goes up, right? Level 1, level 2, level 3, level 4, level 5. So at least when you have level 5, you need to have a lift. Or if you go down to the basement, okay, basement 1, basement 2, basement 3, right? So if you have basement 5, okay, then you need lift, right? But that's just the minimum requirement, okay. So it is not saying that if you have like 3-story building or 2-story building, then no need to provide a lift. Okay, you can also provide, right? Especially for to make people's movement easier, especially for disabled. Okay, so I think today, especially in public buildings, doesn't matter how many stories the building is, then definitely there would be a lift, okay, provided, at least to cater for the need of disabled, okay, on wheelchairs and so on. Right. And if you have been to large bungalows, or maybe your parents own that huge bungalows, okay. So nowadays people even use lifts in the bungalow, right? It may be just like 2-story or 3-story, okay, but it becomes a necessity, right? When we talk about disabled. And sometimes in a bungalow, because probably the owner lives with their parents, elderly parents, so that's why they want to provide ease to their parents. Okay, so they put a lift in a bungalow. Okay, so it's an essential thing nowadays. Right. So okay, so as you can see from the image there, the one on the right is basically a lift, especially for disabled. It might be just a 2-story building, okay. But if there is no other means to provide movement for disabled from one level to another level, like ramps, right? Sometimes your building is too small, okay. I mean, the building area is too small. There's not enough space for you to provide ramp. Okay, so as you know, I believe you have designed a ramp before in your studio project. Okay, so you know that how long you need the length of the ramp, right? For it to reach from ground level, from one level to another level. Okay, so it's very long. So it's easier for you to actually provide lift, okay, for disabled, especially on wheelchairs. Okay, so this is the standards, right, used for installation of lift. So the first one is safety rules for the construction and installation of lift, part 1, electric lifts. And then universal design and accessibility in built environment, code of practice, second revision. Okay, so these are the standards used when you deal with lifts, no, in a building. Okay, so minimum standard of service for lift is 1 lift for every 4-story, and with a maximum walking distance of 45 meter to the lift lobby, right? So it depends, right? So for example, like if you have only 1-story building, four stories. Okay, so if 4-story building, you only need 1 lift. Okay, sometimes you can see in the apartment or flat. Okay, so if a 4-story apartment, sometimes you don't even find a lift in a 4-story apartment. Okay, but the one which is more expensive, okay, so they will provide lift, but sometimes it's just one, right? But if you go to a taller apartment building, let's say 8-story, then as the standard mentioned, right? So 1 lift for every 4-story. So if you have 8 stories, then you need to provide 2 lifts. Okay, so that's one of the things that you need to consider. Another one is the maximum walking distance to the lift lobby. Okay, so if let's say your building is very long, if your building is just the length is about 50 meter, then if you put your lift in the middle of the building, at the center of the building, then it solves your problem. Okay, because the distance from the lift lobby to the end of the building is just about 25 meter. Okay, so it's still within the minimum standard. But if your building is, let's say, 90 meter, okay, so 90 meter or maybe 100 meter, okay, which is a very long building. So if you put only 1 lift lobby in the middle of the building, okay, It doesn't have to be like a one straight line. The building is huge. Okay, so from one point of the room, okay, you travel the travel distance or walking distance from the corner of the room to the lift is exceeding 45 meter. Then you need to provide another lobby. Okay. So for a huge building, for a very long building, normally you need to have more than one lift lobby. Okay, it can be near to the center, or it can be at the end of the building. So it doesn't matter. That one is based on your design. But I believe for your level, at Part 1 level, you don't really have to worry about that kind of stuff, not okay, because normally the building that you're designing is not that huge. Okay, so usually if you just provide like lift lobby in the middle of the building, in the center of the building, okay, then I think that will be sufficient. Okay, and then there are various speeds of lift based on the types and function. Okay, so for passenger lift, to move people from one level to another, for up to 4 floors, then the speed is about 0.3 to 0.8 meter per second. Okay? From 4 to 9, it's 0.8 to 2.0. Okay, 9 to 15, 2.0 to 5.0. Over 15 floors, 5 meter to 7, 7 meter. So paternoster. So anyone knows what paternoster is? I think probably it's not that's so common. Okay, I forgot to put like some image of paternoster, but it's like a moving lift. Okay, it's always moving. So even though like a normal lift, it will stop at every level, right? So when you push the button, and it will stop at that level, and then you have like a few seconds to get into the lift, get in and get out of the lift, and then the door closes and you go up or down. But paternoster basically keeps moving. Okay, it keeps moving, but very slowly, right? So that's why the speed is just 0.4 meter per second. It's quite slow, so you have time to get in. So imagine if you have a ride on the cable car, right? So cable car maybe at Genting or Langkawi or maybe overseas. So you know that cable car never stops, right? Never really stops when you get into the car. So the same concept is actually the same concept as paternoster. So the thing keeps moving slowly. So you need to get in the lift car. So it's a car as well. We call it a lift car, and also to get out from the car. So that's paternoster. Okay. So but these are just reference lah. Okay. So especially if you have if you're designing tall buildings, so the speed of the car need to be very fast. Okay, because if not, then you have to wait for a very long time to until the lift arrives. Okay, but I believe I'm not sure. I think probably some buildings they don't really follow this guideline. Okay, so that's why when you visit a building, okay, you notice that maybe the waiting time for a lift is very long. Okay, and then for goods, this is especially this is for service lifts, right? 0.2 meter to 1 meter per second, and then hydraulic lifts, passenger or goods lift, 0.1 to 1.0. Okay, maximum 4 to 5 floors. Okay, so later on I will show you that hydraulic lifts is actually it's the same lah. I mean, from the inside of the lift, you might not realize, or you might not know whether it's a electric lift or hydraulic lift. Okay, it looks the same. Okay, but the mechanism is different. Okay, so for hydraulic lift, usually it cannot go very high, right? So it is limited to 5 floors. Okay, so the position of the lift lobby, right? So lift should be positioned at location which provide easy access for all building users. For example, central entrance lobby or offices, hotels, apartments, and so on. Okay. This is again it's just a guide, right? But in the end, it depends on the architect or maybe the function of the building. So usually it's going to be right in the middle, right? So if you have been to a high-rise building, okay, you would notice that as you enter the lobby, okay, normally the lobby is like a huge atrium, okay, double or triple story void, okay. Then you would notice that just right behind the lobby, okay, or maybe just next to the lobby is the lift lobby, right? Especially in hotels and apartments and offices. Okay, but in some cases, the lifts, like I mentioned earlier, it could be placed. It's not necessarily right in the middle, but that would be the ideal one, right in the middle. But because of maybe some constraints, it could also be located on other places, maybe towards the side, okay, of the building, or if you want to have two lift lobby, okay, so you can have one on the left side and the other one on the right side. Okay, so that all depends on the design and also the function of the building. Grouping of lifts are essential for user convenience. Okay, so like I said, ideally you should put them all together. So if you look at the image down there, so you have like 6 lifts, okay, grouped together, placed at the center of the building, okay, and then the one with red color is basically the passenger lifts, okay, and then the one in green, okay, you can see that the green color, basically that is the service lift, okay, or maybe the bomber lift, okay. But for today, basically, it's just going to learn about the basic things about lift and also the lift lobby. But I think as you get to masters, if you do your masters, then because in masters you need to design a high-rise building, okay. So in high-rise building, the building core is very important, okay. So the building core basically includes the most important thing in most important component in the building core is the lifts, okay, and then normally all the other services also are placed inside the core, including the toilets, okay, all the risers. I'm not sure whether you have learned about the risers, right? Basically, if you have water supply system, electrical supply system, even telecommunication system. So in a high-rise building, those pipes, right, conduits, everything needs to be placed in the risers. Okay, and I think if you have visited a building for your case study, okay, probably you have not noticed the riser rooms. Okay, so those things are placed near the core of the building, right? But the most important thing is the lift lobby. Another important thing is the staircase, fire staircase. Right. So these are other examples of position of the lift lobby. Okay. The first one you can look at the first one, the Q Central, like KL Central. Okay, the building is elongated, right? It's quite long. Okay, 100 meters long, like I mentioned earlier. Okay, so and you can see that there are two main lift lobby for the passenger. Okay, so label number one is lift lobby, and then so normally for this kind of building, right, if the building is quite long, it is divided into parts. So as you enter the lobby at the ground floor, you would either go to the right wing or left wing, okay, or zone A or zone B. Okay, so normally if for office at the ground level, you would know. Let's say you want to visit a specific office. Okay, like maybe an architect firm. So at the lobby, you already know where is the office located, which wing, which side of the building, which level. Okay, so you straight away go to that side, okay, that wing, and then you push the button, the lift, to go to that level of the office. Okay, so so each wing has its own dedicated lobby. Okay, so you don't have to go to let's say left wing, okay, or wing A. You take the lift at wing A, but in the end you want to go to wing B. Okay, even though it's possible, okay, so from the plan you can see that actually wing A and wing B, they are connected. Okay, the lobby is connected. But to save time, basically from the ground floor, you just straight away go to wing B. Okay, if the building is located at wing B, then straight away you get into the lift from wing B. Okay, and then from the image also you can see that at the near the lift lobby, there are a lot of other components, services components, including the toilets, okay, staircase, service lifts, and also the risers, right? In case you are not sure what riser is, okay, basically it's here. Okay, you can see my pointer, right? Okay, so normally from the plan you can see that like a small small doors, okay, small space like that. It looks like a cupboard or something. Okay, so it's riser, one for water supply, one for electrical, one for telecommunication, okay, and so on. Okay, basically what's inside the riser is the pipes. All right, and then at the bottom there you can see another example. The one is in a hotel. It's a firefighting lobby design. So basically it's a lift lobby, okay, but it's protected. Okay, you can see that the lobby is protected with the door. Okay, this is right. And then together with the inside that core going to the staircase, okay, and also access to the fire equipment. Right? So basically, the firemen would access when they access that space. Okay, they will get to the firefighting equipment, and then they would fire from there. Okay, next, the Kiara typical floor plan in the Setia Alam. Okay, even though the building is quite long, but it's only I don't think it's more than it's 100 meter, so maybe it's just like 50-60 meter, right? Looking at the okay. And normally in apartment sorry, I was disconnected.
Mr. Adib, are you there? Mr. Adib, can you hear me? I think Mr. Adib is facing a bad internet connection. We wait for him.
Hi. Hi, Rizal. Hello.
Mr. Adib, I think it's better for you to turn off your camera.
Okay, but can you hear me now?
Just give a lecture. Okay.
Boleh. Can you hear me now?
Slide and your voice.
So can I proceed? Okay, can I proceed?
Can you show us the presentation slide?
Yep.
Okay, we can see the presentation slide.
Okay, can you hear me?
Can I hear your voice?
Cannot hear. Cannot hear. Can you hear me now?
Yes, we can. I can hear you. Guys, can you hear Mr. Adib? Ryan?
Yes.
Can,
okay,
right?
good. Okay, you can continue, Mr. Adib.
Okay. All right. Okay, so so as mentioned, the lift lobby for apartment can be placed right in the middle. Okay. Together with the fire escape or normal. That's in Mandarin Palace. Sorry, Federal Hotel, Kuala Lumpur, where you can see there are two lift lobby. Two lift lobbies, one with 3 lifts, lift core, and in many different varieties. So probably like the one on the lobby on the right is to serve like the rooms, straight away to serve the rooms on top, on upper level. But the one on the left is probably both probably to serve the rooms as well. But at the same time, because it has many different like conference room, Penang Suite, Selangor Suite, Melaka Suite, and so on. Those are, I believe, those are like conference rooms, right? And so basically there are more public using these rooms, so that's why there are more lifts in that lobby. Okay. Okay, so lift grouping. So when a number of lifts are required, it is preferably to group them together, right? As I mentioned earlier. So basically, I think it doesn't matter where you go, you will see that the lifts are grouped in one area, in one lobby. Okay, so basically it's to reduce waiting time. So you don't have to wait for one lift, okay, to get to another level. Okay, so basically when you group the lifts together, you have like 3 lifts or 4 lifts or whatever number. So usually when you push the button to go up, okay, so all the lifts would actually respond to that. Okay, so maybe so you just get into the one that arrives at that particular level. And also to reduce cost of installation. Okay, so basically the cost means that because when you install a lift, you would require a lift core. Okay, lift core is basically made of concrete. Okay, the wall of the lift to enclose the lift made of reinforced concrete, which is actually quite thick, right? So it costs money. So when you put all the lift core together, okay, so basically you reduce the number of the core walls, right? Compared to if you put them at different locations. Okay, according to EBBL, by law 153, a smoke detector to be provided at the lift lobby. Okay, and then lift lobby should be large enough to allow traffic to move in 2 directions. Okay, this is some reference to the size of the lobby according to the number of lifts, okay, in the grouping. So if you have 4 lifts, so normally 2 lifts on one side, the other 2 lifts on the other side. Okay, the width of the lift is between 3.5 to 4.5 or twice the car depth. If you have 5, but very unlikely, very unlikely you have odd numbers. So most of the time you would see even numbers, okay, either 4, 6, 8. Right? So when you put it in the lobby, in the lift lobby, so you can see that this is symmetrical. So you have 3 lifts on each side. Okay, so if you have 3 plus 2, then it looks a bit weird. But the width is the width of the lobby is the same, 3.5 to 4.5. Okay, so basically it's to allow for uninterrupted movement of passengers, those who wants to get into the lift and those who wants to get out of the lift, right? But if it's only one side, for example, like the one in you find in Taylor's, right? You have 3 lifts grouped together, but only on one side. Okay? So the lift, the lobby, okay, the area in front of the lifts can be not so big, as it can be just around 3.5. Okay, but you also in Taylor's, if you look at the one in Taylor's, you also need to consider the movement of people who are taking the stairs, okay. So normally because they just imagine block E, right, where your studio is. So if some people they take the stairs, so because the stairs is a single flight, okay. So you get to the floor and then you have to turn around to get up to the next level. So when people turn around, they have to walk past by the lobby. Okay, so you have to consider the basically the lobby needs to be huge enough to cater for people waiting for the lift, as well as people moving from the staircase. Okay, so yeah, I think you can just look at the slides now for reference on the sizes. The one in the middle is basically you have two groups. So the one on top is basically like if you have one lift lobby right in the middle of the building, so that's how you can arrange. So if you have two groups, like I mentioned earlier, if the building is quite long, so you have two wings, two sides. So the arrangement of the the lift is like that. Okay, and also if you have 6 lifts in each group, right? So that's how you can arrange. Okay, number of lifts. So these are just guidelines. So if you want to decide on the number of car required for office building and hotel, so you can refer to that. So for hotel, they go by the number of rooms, right? So for big hotels, for each room, so how you read that is basically if you have 90 rooms, okay, for the hotel, you only need between 90 to 120 rooms, you only need one lift. Okay, if you have like that one is for service oriented. For cheap hotels lah, budget hotels or economy hotels, for 150 rooms, you only need one lift. Okay, but nowadays I think if you go to any hotel, doesn't matter whether it's a budget hotel, at least you would have one lift, okay, to help people to bring the luggage back from the lobby to the upper level. But for office buildings, if it's service oriented, it goes by passengers. So you can see the difference, right? For office building, the calculation is based on passenger. For hotel, is based on number of rooms. Okay, so for luxury office building, then you can use that guidelines. 150 passenger for every 150 people in that building. So you have to provide one lift. Okay, so that's why, for example, if you go to KLCC, okay, so it's a very tall building, and then so many people there. So you can see a lot of lifts, right, inside the in the lobby. Okay, factors determining the number of lifts. First is the population of the building, right? So you need to remember this. Probably would come out in the exam. Population of the building, so number of people inside the building. Okay, so population can be estimated by allowing between 1% to 9.5 meter square to 11.25 meter square of the building's floor area. Okay, so if let's say, for example, you have 100, your building is 100 square meter. Okay, if you go by this reference, okay, 100 square meter building, then the estimation is just about 10 people. Okay, 10 people inside that. The population of the building is just 10 people. Okay, so if you're 1,000, then 100 people, so something like that. Right, so you have to allow 1% to between 9.5 to 11.25 meters square. And then another factor is the type of building occupancy. Okay, whether it's a hotel, it's an office building, a hospital, right? So for hospital, normally you need to have a bed lift, okay, which is commonly located close to operation theatre in the hospital. And then another consideration is for residential building, usually require less lift compared to commercial buildings. Okay, right? Because in residential area, people don't really move that often. Okay, from one level to another level, so they don't really move that often compared to office building, right? So that's why we require less number of lift in the residential building. Okay, number of floors and height. Okay, as the number of floors increase, the number of lifts required also increase. Okay,
because it takes time to reach from one level to another level. The initial costs, as the number of lifts increase, installation costs and capital costs also increase, right? So if you are designing a building and the client is on a budget, right? So maybe one of the costs that you can consider to cut down is on the cost of the lift. So maybe if it's not really required for the building to have a lift, then you can just cut down that part to save costs. Maintenance costs. As the number of lift increase, maintenance costs also increase, right? So if the building is really is a budget building, so the client also has like a low budget for the building, and then the maintenance also. So once the building completed, then the budget for maintenance also is not that high. Then might as well not to have the lift, okay? Because it is costly to install the lift as well as to maintain the lifts. Okay, and then you can see there are a few different capacities of the lift. The standard one, 15, 20, and 34%. Okay, but there's also like the smaller ones, just about 6 people. Okay, and so on. So the less number of lift provided, the longer the waiting time. Okay, so if you have a huge building, but the number of lift is very little, then people would have to wait for a very long time until the lift arrives. Okay, quality of lift performance is determined by the hoisting capacity or handling capacity. So how many people can the lift carry at one time. Is actually a measure of how quickly a set of lift can transport all passengers to their destination at the peak period. Okay, so this is calculated based on the peak period. Right? So if it's non-peak period, then it's not really a problem. Okay, normally the lift would arrive quite fast because nobody else, not so many people are using the lift. But during the peak period where everyone wants to use the lift, for example, like during in the morning, right? Like in Taylor's, you can see the peak period is usually in the morning, afternoon. Okay, normally after the class ends, before and after the class ends, before the class starts and after the class ends, 8 in the morning, 8, 10, 12, okay, that kind of times. But I think the most peak will be in the morning. It's affected by the number of lift and the size of the lift car. Okay. And then waiting interval, so maximum time in seconds between call registered in the main lobby. So when you push the button, okay, when you call the lift, you push the button during peak traffic condition and the arrival of lift. So how long have you need to wait? Right? You need to wait for the lift to arrive during the peak hour. Okay, depending on the opening and closing speed of the lift car, the acceleration rate of the car, the speed of the lift, the time taken to enter and lift the lift. Okay, so that's quite technical. Because actually lift is like a specialist job lah. Okay, I think probably you have heard some very popular names of lift manufacturers, right? Like there are a few of them. Okay, but your role as an architect is basically the most important part that architects need to do regarding lifts is basically to include, right, the lift in the design. Okay, so basically as an architect you need to plan out where to put the lift lobby. Okay, and then roughly you need to know how many people, how many occupant in the building. So from there, I mean you would be able to estimate how many lifts required, right? But as an architect, you don't really have to know the details, the process, and so on, because as you know, like this is technology, right? So technology evolves from time to time. Okay, but what you need to do is basically to provide the space for the lift in the lift lobby, and also in your design, you need to include that. You need to indicate that lift core in your design. So in the floor plan, if you have lift, then the core should be shown on the floor plan, right? Because actually the lift core forms part of the building structure, right? So normally, because it is constructed using reinforced concrete, so if you have lift core, then you don't really need to have like reinforced concrete column to support it, because the walls of the lift core is basically made of reinforced concrete. Quality of ride is determined by smoothness of the ride, the degree of noise, accuracy of floor leveling, lift lobby design, lift car interior, ceiling finishes. Lift for the lift car interior. So normally what you can do is probably as an architect or interior designer, you can decide on the ceiling finishes and also the floor and walls finishes, right? So what kind of look that you want to have in the lift, right? So that one you can design. Okay, the design requirement is basically the lighting level, right, inside the lift. So basically, if you want to have a very comfortable, luxurious lift car, so maybe if the lift is inside a hotel, luxury hotel, then you might want to consider on the lighting inside the lift, right? Just like the example shown here, and the sound system, right? You have music. Sometimes in the lift nowadays you can see like LCD screen. Okay, while waiting for the lift to arrive at the destination, you can just watch something on the screen. Okay, so there are many kind of lift nowadays, and also other emergency escape provision other than the doors of the lift car. Okay, so it is also required to have basically there's an emergency exit door on top of the roof of the car lift. Okay, so from the image here, you can see that actually that's the emergency door. So if let's say the lift starts, then by right, the top of the roof, okay, the top of the lift should be able to, you should be able to open the top of the roof to escape. Okay, zoning of lifts. For skyscrapers or super high-rise building, it is necessary to divide a building into groups of elevator serving floors, called zones, right? For example, in low, middle, and high zones. Okay, if you have been to a high-rise building, if you have been to high-rise offices in KL or maybe any other place, okay, so you would notice that the lifts are divided into zones. So not all the lift goes to the same floor. Okay, so you need to know if you are going to, for example, if the building has like 40-story building, if you are going to level 38, so you need to know which lift that you should take. Okay, which zone that you have to take the lift. Okay, normally it is shown maybe on the wall, right? Showing that this lift is going to between which level to which level. Okay, maybe just from ground to 10. Okay, so the other lift is going from 10 to 20. So another lift is from 20 to 30. So things like that. Okay, so if so basically is to provide every passenger with equal elevator service as possible. So for example, like if you want to, if everyone goes to the using the same lift to go to every level, right? Then people have to wait longer, okay, because the lift would go. Just imagine the lift would stop at every level from ground to 40th floor. Okay, So by the time you arrive to the 40th level, then maybe it's 1 hour already, right? So that's why we need to have zones so that you can arrive at the destination faster, okay, compared to if everyone takes the same lift. Recommended number of servicing floors for each group is between 10 to 15. So if the building has 45 levels, then maybe it's okay to provide like every 15 floors, zoning for every 15, okay, 15, 30, and 45, right? So if you have 40, then maybe zoning for every 10 levels, okay, so 10, 20, 30, 40, something like that, right? So you can see from the section there, from the image there. So even though there are zones, there are also like few elevators or few lifts going to every level. So the one on the left is basically the express elevator, right? This one here, you can see that it goes from ground to the top, right? So this is basically for servicing mechanical, because if let's say the mechanical equipment room is at the rooftop, right? So this is for servicing. So people who wants to service that components, the mechanical services, so they can straight away take, because they of course they would arrive on the ground level. Okay, if the parking is at basement or at the ground level, so they have to take lift from the ground level and goes up to the straight away to the rooftop. Okay, but the other lift, maybe you can have another one servicing from ground level to the sky lobby here, right, to the top of the second zone. But the rest, we call it local elevators. Okay, so local elevators basically just serve lifts within that zones, right? So from here you can see basically there are like two types of zoning. So the first type is this one. So for like, let's say this is like 30 levels, for example. So every 30 levels, there's one zone, and then another 30 levels, right? Okay. And then inside that 30 levels, you have like a few lifts. So maybe every 10 floor, okay, within that zone. So you have zoning of the lift. So every 10 floor, one lift, okay. So another lift, right? So in each of the zones, okay, this is for a very small. Okay, can you hear me, Rizal?
Yes, yes.
Suddenly it got it got disconnected. Okay, so you can see the slide, right? You can see the slide.
Yes, yes.
Rizal? Okay. All right, so from this image, you can see, from this slide, you can see a different arrangement of lift, different design of building core, okay, and also different arrangement of the lift in the lift lobby, right? So I think, like I said, when you get to the master program, if you continue your study in part 2 or master program, you're going to design a high-rise building, okay, multi-story building, high-rise building, where you're going to design the core. The core of the building is one of the most important thing for a high-rise building. Okay, it can be in many forms, but from these images you can see how the lifts are arranged, right? So the first one here, okay, the shape is quite unique. You can see that there are two sides, right? So one here, so another one here. So probably there are zoning as well. So maybe the one here goes to like certain levels. Okay, the one here goes to certain levels, right? So it could be that way. And then same goes to the other, like this one, more probably this one is taller. This building is taller because you can see there are so many lifts. In total, from this plan, you can see the passenger lifts. There are 24 lifts. Okay, so probably each site here goes to different levels, right? Different zones. And then same goes to this one. But here, so basically the passenger lifts are located on this side and this side, right? Where the offices are, most of the offices are on this side and this side. Right? I would say the arrangement is not that nice lah, so it can be quite confusing. Okay, compared to the other core, okay, the other lobbies which are more. I think the design is well thought of. The other in the other building. Okay, and then this one is quite simple. Okay, the core of the building is round, right? It's a round core, and with 5 lifts, all in on one side, right? And then the staircase, fire escape, okay, fire staircase at the back of the lift core, okay, and then there's the toilet, right, washroom here on this side. Okay, I think this is quite nice, the design of the core or the lobby. But one of the disadvantages of having this kind of lift, if you have many lifts, but all of them are placed at one side like this. Okay, I believe you have encountered the problem before. So where all the lifts are placed at one side. So if you are on the left side, if you stand here, okay, and then you push the button for this lift, but then suddenly the one that arrives is on the right, so you have to go to that side. Sometimes you can't, you didn't notice, you didn't realize that the door is opening because you cannot see. Okay, so in the end you have to stand in the middle so that you can see all the lifts, right? So for me, that's one of the disadvantages of having this kind of arrangement. Okay, but if you group them like this, okay, if you have 4 lifts on each side, okay, and then the possibility for you to see, okay, all the lifts is higher. You can see better. Okay, benefits of zoning. Carrying passengers to their destination zone as fast as possible. Express zones are provided to run express or shuttle elevators between the lobby and each zone. This will also maximize high-speed elevator performance, reduce round-trip time, increase passenger handling capacity, and reduce the required number of elevators. So if you look at this image, this is the one that I mentioned. So normally on the wall, right, at the wall, you can see that so let's say, for example, on this side, the left side, okay, I believe the lifts are on this side. Okay, you cannot see it from here. So the lifts on this side goes to level 10 to 18. Okay, so the lifts on this side goes to level 2 to 10. Okay? And then there are a few more signage at the back there. So probably they are going to different zones. So maybe this one here goes to between level 18, okay, 18 to 28, for example, right? So something like that. So this is another example. You can see on the wall here, okay, it says high zone, okay, goes to level 17 to 31, right? So if you go to this level, there are some offices that located at this level between 17 to 31. So people has to go to this zone to go to that level, and probably there's another lobby, okay, at a different side of the building, goes to a different zone. Okay, space benefits of zoning. Space above the low and middle zone elevator hoistways in the building is available for use as offices and other purpose. Okay, so if you look at this image here, right, what it means is basically here, this level here. So you can use this space here for office, right? So you compare between the ground level. So at the ground level, because all the cores are there, right? So in the end, the usable space is quite small. So this space is right? Compared to here, this gets bigger. So you have more space that you can use for office. And here it gets even bigger. You have more space for the office. And here, right, this is the biggest for this zone, right? Where you can have more space for office. So basically that what it means. The elevator hall space between express elevator serving floors is also available for use as storage, right? Same as more or less the same as same function as the one above. Rentable space in the building will thus be increased. So basically in office building, the profit comes from the rent, right? Okay, so you would be able to rent out more spaces, okay, if you have zoning. Basic components of a lift. Okay, basically this is in general, right? Afterwards you can see that there are some variations of lift design. So the most basic components would be the machine room. There's also a lift without machine room, but in the past these are the basic things. Normally a lift would have the machine room or the motor room, which includes the motor control unit and so on. And then from here you can see the basic dimension as well. So especially the motor room is about 2.6 meter high. And then of course the lift car. So this thing is called the lift car. The one that you enter in the lift is called the lift car. The counterweight, right? So basically to balance, not to say the balance, basically to reduce the amount of weight that need to be lifted by the machine, and also the pit. Okay, so basically the bottom of the lift, right? The floor is not flat, right? It's not. Let's say this is the ground level, so the lift actually does not. I mean the lift core. So the whole thing is called the lift core. The grey area is called the lift core, but the lift core doesn't stop at the ground level. So it is extended down a bit to form the lift pit, right? So for emergency, like if let's say the lift car is out of control and it drops down to the ground, so basically there are like buffer, right, at the inside the lift pit. Okay, so what's inside the machine room is basically so basically machine room is one component of a traction lift. Okay, later on I will show you that there are two types of lift. One is traction, one is hydraulic. So for traction lift, the one that uses cables, we call it traction lift. So machine room is one of the main component. Preferable to be sited at the top of the lift to minimize the length of rope and optimize the efficiency. I've never seen any building that has the machine room not above the lift. Okay, so most of the time is going to be above the lift core or the lift shaft. Should be ventilated, right? So you need to provide some ventilation. And the machine room can also be placed at lower level, but it requires longer rope and more pulleys, as well as increasing the maintenance cost. So like I said, normally from what I've seen, from what I've found, basically the lift motor room is located on top. These are the components, right? I think you can have a look later on. Okay, so another main component. So this is similar to both traction and hydraulic lifts, right? Definitely you need to have a lift car. So if for all the lift system, definitely you need to have a lift car, right? So if not, then how would you use the lift without the lift car? So basically the car moves in a vertical shaft to carry passengers or freight between the levels of a multi-story building. Okay, I think everyone knows that. Most modern elevators are propelled by electric motors with the aid of counterweight. Through a system of cables and sheaves or pulleys. Okay, for traction lifts, right? So it needs cables, pulleys, and then for the lift car, you can see that apart from the usual things you found that can be found inside the lift car, right? The control panels and so on. So sometimes you cannot really see this emergency trap door, right? But it is there. And then above the lift car, basically there's something, I mean, this what you call it, balustrade, especially to carry out maintenance of the lift, right? So the maintenance personnel would actually stand on top of this lift car, okay, to maintain the lift. So they need this balustrade for safety to prevent the maintenance workers from falling down into the lift shaft. Okay, counterweight is basically a heavy, basically counterbalance the load of the elevator carriage. So the motor lift much less, the motor lift much less of the carriage weight. Okay, so let's say the total weight of the lift car is 1,000 kilogram the capacity, but this counterweight, I don't know exactly how heavy it is, but let's say this is the total weight here is like 500 kilogram. Okay, so basically the motor of the lift just need to lift up, let's say only 500 kilogram instead of 1,000. Okay, even though the capacity of the people inside the lift is 1,000 kilogram. Okay, but because of this counterweight of is 500 kilogram, so the motor only needs to lift up 500 kilogram. Okay, something like that. Okay, lift shaft and pit. Okay, the size of shaft required depends on the size and speed of the car, also the type of door gear. So last time when I was a student, I'm not sure whether all of you has the Newford. Last time my reference was new metric handbook, right? So basically inside that handbook you can find all the dimensions that you need, from transportation, lift, whatever you just name it. Okay, anthropometry, so everything, including lift. So normally last time when I was a student, when I designed the lift core, I would refer to the handbook. Okay, so if the capacity is this big, let's say 10 people, so what's the size? So you can just refer to that. You can just take that reference. So okay, another way to make reference is probably you can find a manufacturer of the lift. Normally they would have like a catalog with complete size and dimension. Right, so lift shaft extended below to form the lift pit. So basically this is the lift pit. This is what lift pit looks like. You can see this is the buffer. So just imagine that the cable of the lift, okay, so basically snap, and the lift car moves down, right? So it won't straight away crash to the ground, to the cement, right? But there would be this buffer. But I don't know how severe it's going to be, like, even with the buffer. Okay, but at least there's something to stop the car lift from crashing to the ground. And as you know, like in the lift, basically there's a gap, right? Sometimes between the floor and the car lift, there's a small gap, and people would sometimes drop things in between the gaps. So in this image here, it's basically like a notebook, right? It's a book or something. Probably fell from between the gap. It goes down. In some other cases, maybe in apartments where the maintenance seldomly carried out. So you can see some images online. A lot of trash inside the lift pit. Okay, lift pit must be watertight and drainage to be provided. So from here you cannot see the drainage, right? But because basically the lift pit, if let's say your building starts at the ground level, okay, there's no basement, so the lift pit would extend down below the ground level, okay, so actually below the ground, so below the ground. So if it is not watertight, if it's not waterproof, then the water from the ground would actually seep into the wall and would actually flood the pit. Okay, so it can be a breeding ground for mosquitoes and so on. It's quite dangerous. Okay. Okay, types of lift or elevator. Okay, there are two main types of lift, as I mentioned. First is traction lift, and the second one is hydraulic lift. Okay, so traction lift, there are two variations. One is traction with machine room. So another one is machine roomless traction. Okay, both are traction, but one with machine room, another one without machine room. So you just need to remember that. Okay, so traction lift lifted by ropes, cables or ropes here. Okay, so just like the one that I've shown earlier. Attached to an electric motor above the elevator shaft. Okay, so inside the machine room that I've shown earlier. Used for mid and high-rise application and have much higher travel speed compared to hydraulic elevators. They're faster compared to hydraulic lift. Okay, and it is used in taller buildings. Okay, for low-rise building up to maybe 4 or 5 story, you can use hydraulic. But taller than that, you need to use this traction lift. Okay, one of the, not to say disadvantages lah, but depends. Some people might find it as a disadvantage. Some may not. Okay, if you are using a lift with a machine room, okay, so from this section you can see that basically you need to have like if let's say your floor stops at this roof terrace, okay, level 38 here, but the machine room would actually extend up a little bit more. Okay, maybe like 4 meter. It depends lah. Just now I show you the minimum is about 3 meter. Okay, so if you are not doing anything to the facade or to the elevation, so from the elevation of the building, you are not doing anything to cover that part. So you would be able to see that the extruded part, the protruding part. Okay, so basically from the elevation you can see the shape is like that, which is for me maybe it's not nice lah. But as you can see from a lot of high-rise buildings, right, in KL or anywhere else, the shape of the roof is sometimes quite unique. So it looks like that. It looks slanting like that. Okay, like this elevation, or you can put you can do something to hide, basically to hide that part. Okay, the services part on the rooftop. So from the elevation, it would look nice, but inside it's actually like this. Okay, so there's the lift motor room on top. Okay, but I think probably buildings in the 80s or 70s, because I think only nowadays people, when they design high-rise building, they will cover up that part. But previously in 80s or 70s, a lot of high-rise building, you will be able to see that machine rooms or maybe the water tanks on top of the roof is not covered. It's exposed, right? Okay, even from this section, so you can see some kind of zoning of the lift, right? So this lift only stops here. Okay, so another lift goes to this level, right? So there are different zoning. So another one is machine roomless traction. Okay, so the difference between this one and the previous one is one with machine room, another one is without machine room. So basically for this kind of lift, the mechanism is more or less the same. It's just that there's no machine room on top. Right? So the motor is basically located inside the shaft itself. Okay, so the machine sits in the override space and is accessed from the top of the elevator cap when maintenance or repairs are required. I believe this is the system that we use in Taylor's. Okay, so basically, if you look at Taylor's, the blocks, academic block, okay, you can see that there's no protrusion. The highest level is level 9 lah, where the academic suite, the lecturer's office is. You cannot see like a machine room on top of that level. Okay, so maybe afterwards you can see lah. Maybe after this, if you visit the level 9, you can see. You can look at the other block. My office is at block C. So from block C level 9, you can look at block D level 9. So there's no machine room on top, right? And then we lecturers, we always see people carrying maintenance work from level 9. So the maintenance workers of for the lift, they actually access the lift from level 9. Right, so they don't go up to another level because there's no other level. There's no machine room on top. Okay, so basically Taylor's is using this kind of lift. I think a lot of modern buildings nowadays, they are using this kind of system. Right. Maximum travel distance up to 76 meter and can travel at speeds up to 152 meter per minute. Okay. It's low energy consumption compared to the other one. Okay, advantages of this machine roomless or MRL traction: improve aesthetic view of the building. Okay, so if you look at this section compared to the one previously, you can see that there's a protrusion. Okay. Of the lift machine room, the lift motor room on top of the roof. Okay, let's say this is the rooftop. So on top of the rooftop, you have another space on top. Okay, for the one with the machine room. But using this MRL traction, so there's no need for that space. So basically, the floor can just end at that level. But usually this top floor here, okay, the ceiling height, it needs to be slightly higher. Okay, because the lift will actually stop somewhere here, so you still need to have like little space here, okay, to place the motor, right? It cannot be the same height as the other floors. Okay. Okay, same goes to Taylor's. Basically, the top level, the roof is made of is using roof trusses. So basically, the ceiling height is higher. Okay. So even with this machine roomless, it can be either on top or at the bottom, but inside another space. But normally it would be advisable to use this one, very straightforward. So all the machine, everything is within the shaft itself. Okay, but even though it's machine roomless, but it still requires the pit. Okay, so pit is required for all type of lifts, as I mentioned, whether it's machine roomless or with machine room or hydraulic lift, so all needs to have the lift pit. Okay, so comparison between traction with machine room and MRL traction. So between these two, so one is with machine room, another one without machine room. So there are pros and cons, right? So if you look at the maintenance workers' perspective, okay, basically they would say it's more difficult to maintain, more difficult and more dangerous to maintain this machine, this lift without the machine room, because they have to stand above the lift car, okay, and there's a risk of falling down, okay, from the lift car to the shaft. But if there's a machine room, so they can comfortably stand on the floor, right, without having to worry about the risk of falling, okay, and then they can see all the components clearly, right? So that's from the workers, okay, maintenance workers' point of view. But in terms of design, of course, the one without the machine room would look sleek. So compared between this one and both are in Singapore, both buildings are in Singapore. So the one on the left is with machine room. So you can see that the height, the level of this is the lift shaft, and then on top of the lift shaft there's a motor room, okay, which is extended above the high above the roof level. But the one on the right is without machine room. It is slightly extended lah, but not as tall as the one with machine room. Okay, probably because the height, they want to maintain the height of the house the same, similar from ground to the roof. Okay, so let's say all let's say 3 meter. Okay, so all levels 3 meter. So because of that, they have to extend just a little bit compared to the one with machine room. Right. So another one is hydraulic lifts. Okay, hydraulic lifts. Rather than using cables, okay, it is supported by a piston at the bottom of the elevator that pushes the elevator up as an electric motor forces oil or another hydraulic fluid into the piston. Okay, so basically the motor or the piston, the motor is located in a room next to the shaft, okay, but not on top, right? So if you look at this diagram, it's located at the side of the shaft, and then there's a hydraulic fluid inside the pipe. Okay, so basically it will pump the oil, okay, to move the piston that pushes the car, right? So this is the piston, right? So basically the mechanism is very different from the traction lift. Okay, the elevator descends as a valve releases the fluid from the piston, right? So that's how it works. Okay, this kind of lift is used for low-rise application between 2 to 8 stories. Okay, earlier I mentioned maximum 5. It depends, or maybe because it's technology, right? So technology evolved. Probably nowadays they can make hydraulic lifts that goes to higher levels, right? And then travel at a maximum speed of 61 meter per minute. The machine room is located at the lowest level, adjacent to the elevator shaft. Suitable for goods lifting, lift for hospital and old folks home. Okay, because this is very smooth, right? Because using hydraulic, the movement is very smooth. Okay, so that's why it's good to be used in hospital, old folks home, right? And then it's quite strong, so you can lift up goods or services, things. Advantages of hydraulic lift: operation is simple, lower maintenance costs. The load imposed is lower compared to electric traction lift. No need for brake, ropes, pulley, driving shift, and so on. So no need counterweight, and you can have larger lift. Extremely accurate for floor leveling can be achieved. Acceleration and travel is very smooth. Okay, so those are the advantages. Okay, so comparison of floor space utilization between different types of lift. So the first one on the left is traction with machine room. The one in the middle is machine roomless. The one on the right is hydraulic. Okay, in terms of the space usage, you can see that the machine roomless is the best, right? Because it requires less space, right? So between the traction with machine room, it is lesser by 35% usage, and compared to hydraulic lift, lesser, reduced space usage by about 30%. Okay, but of course, in the end, it depends on the purpose of the lift itself, right? Okay, elevator controls and indicators. So this one is in the lobby. So in the lobby, what is required is the floor designators, right? Which level so everyone inside the lift or from outside the lift should be able to see clearly which level they are at. Okay? So you can see here the level indicator, level 3, located at the side of the door and also on the wall here. So people inside the lift, so they would know at which level they are stopping every time. And then the call buttons, and that's the usual stuff if you want to call the lift. And then the hall lantern. Okay, basically the light here showing whether it goes up or down. Okay, showing which elevator or which lift is actually stopping at the moment, and whether it goes up or goes down. Okay, so that is the hall lantern. Elevator car controls. I think this is quite straightforward. Floor selection, buttons, operation and maintenance, emergency buttons. Okay, key switch control for maintenance, and so on. Okay, users of lift. The first one is, I think everyone knows, passenger service. Right, this is for normal lift. Also for bubble lift or glass lift. This is the bubble lift I mentioned earlier. Normally used in shopping malls or sometimes in hotels. This is glass lift. Okay, rather than using reinforced concrete shaft, we can also use steel structure, to replace the reinforced concrete shaft, and then covered with glass. Okay, to allow people from inside the lift to look outside. Okay, and then it looks nowadays it looks nicer, right? If you do this back then in 80s or 70s, I think everyone would curse you, maybe. Okay, but nowadays it's kind of becoming a norm to see this kind of lift shaft. Right? And then to lift goods or freight, I mean like boxes, okay, things lah, basically, other than people, right? Cargo and so on, and also for vehicle elevators, right? So this is for vehicle. The concept is similar, okay, but rather than like the passenger gets into the lift, okay, so the whole car with the passenger, with the driver, gets into the lift. Okay, I've been to this kind of lift. I think there are maybe a few buildings in KL also has this vehicle elevators, right? So, but the concept is similar, right? But at one time, only one car, depending on the size, I believe only one car. I'm not sure if there's any other lift with more than one car that can enter the lift at one time. Okay, so this is useful if, let's say, the building is located at a tight space and it cannot provide ramps for the car to go to the parking area, the parking lot. Okay, so the space is very tight, so you cannot design the ramp. Then this is the solution, right? So you can provide the vehicle elevator. And nowadays, I think in I think luxury condominiums in overseas, I'm not sure if there's any in Malaysia, but they comes with private elevator lift. Vehicle elevator. So meaning that basically the residents, okay, they can get into this vehicle elevator, the car lift, and then they can park inside their condominium unit. So if, let's say, the condominium is at level 50, so they can park the car inside that the same level, just next to the house, okay, at level 50. So using this vehicle elevator. Okay, other uses is residential elevators that I mentioned. You can also install lift in the bungalow, okay, and also dumb waiter. I'm not saying that this waiter is dumb, okay, but dumb waiter is actually this thing, okay, not this person. Okay, dumb waiter is the name of this kind of lift, right? So it's a small lift, small elevator to carry objects rather than people. So normally used in restaurants, hospitals, and so on. Okay, if you have been to GB&Co at Empire, so you can see this dumb waiter is quite obvious. You can see it. Okay, this is like a lift for wheelchair. Okay, even though the level is quite low, right? Maybe just 1 meter, but because you cannot provide a ramp, then as an alternative, you can provide this wheelchair lift. Okay, it's quite common in Europe, but in Malaysia it's not so common lah. So people will use ramp more often compared to this kind of lift. Another one is stage lift. This part here. Okay, so basically it's the to move the stages, the stage. okay, rather than just having a flat stage. So depending on the event, whatever event, so the stage can be moved up and down, okay, to make the effect more dramatic and so on. Okay. The second one is escalator. Okay, escalator I think is quite straightforward. Compared to lift where we have to wait, right, to get into the lift to get to a different level. So in escalator, basically it provides immediate means of transportation. Okay, it is non-stop. Okay, you can easily get on it and it continuously conveys to move a large number of people. Okay, can help increase sales on all shopping levels. Okay, as ordinary stairways limit customer frequency on the upper floors. Okay, so how many times you take staircase from one level to another level, right? Be it in the shopping mall lah. Okay, so normally I would say maybe some people they never take staircase, right? So they will either take lift or escalator. Okay, so this is what it means, because if let's say the escalator is provided in the shopping mall, then it would increase the sales on the upper level. Okay, so basically all levels will have I mean the sales would be the same lah, I would say, okay, for all levels. But if they don't provide escalator in shopping malls, then nobody higher to the upper levels. Okay, right? And if you ask me, I don't really like to take lift also because you have to wait, right? So in the end, so you just walk on the ground level lah. You are not going up to the other level. Quick and efficient, no waiting time required, can be reversible to suit the main flow of traffic during peak times. Okay, so it should be located at location easily seen. Carrying capacity of escalator depends on the speed and the width of tread. Right. Only yesterday I came across this huge billboard, right? Driving from when I drove from KL to Taylor's. Okay, there's a huge billboard. I think from what, Schneider or what was it, the name? So they claim that they installed the longest escalator in Malaysia in the Bukit Bintang MRT station. I believe this is the one, so I don't know how long, but they claim that that's the longest in Malaysia. Right. But if you have been to MRT station, you would notice that the escalators are quite long actually, okay, because they go underground. Okay, they go very deep underground, so that's why it's quite long. So escalator arrangement, the first one is single bank with interrupted traffic in one direction. Okay, so meaning that you go up one level or you go down one level, and then you have to turn around, and then you go up again, same direction. Okay, so usually used in shopping malls, which is not so high, right? Basically to encourage people to walk in front of the shop. So of course in shopping malls, right? So people they want you to shop lah, right? Shopping malls. So as you go up the level,
Mr. Adib, we cannot hear you.
Hello?
Yes, Mr. Adib.
I don't know lah what happened to my internet. Okay, just a little bit more. I might need to extend a bit the time. Is it okay, Mr. Rizal?
Yes.
Okay. Which was the last part? Escalator.
Yes.
Okay. The longest escalator in Malaysia. The escalator arrangement, right? Okay. Right. So, okay. So that's the first arrangement. Single bank with interrupted traffic in one direction, meaning that it's not like one. Meaning that you have to walk around in front of the shops before you get to the escalator going to another level. Okay, the second one is single bank with traffic in one direction. Okay, so basically this one is quite smooth. So you go up one side. Let's say this one, you go up, okay, and then straight away you would find another escalator up here. Okay, so just one direction, and you can go from ground straight away to the upper level without having to move around, just like the previous one. Okay, so the easiest one, I think nowadays you can even find this kind of very long elevator. Like I said, if you go to MRT station, you would find this kind of long elevator. Okay, so usually used in transportation hubs as people need to move very fast. Okay, in shopping malls it's different because normally you're not rushing, right? When you go to shopping malls, you're not rushing. You are there to shop, so that's why they want you to move around, look at the shops before you take another escalator. But in transportation hubs, everyone is moving very, very fast, so that's why the escalator needs to be in one single traffic, okay, in one direction. So another one is parallel, okay, parallel or crisscross, okay. But basically the movement is you don't have to move around to get to another escalator to go up or down. So from here, basically, let's say here you go down, right? You go down and then you arrive at this level, and then straight away you can go down. Okay, so you don't have to move around the shopping mall. So normally this is for high building, even though it's shopping malls, but if the shopping mall is quite high, then it's more convenient to have this kind of arrangement, okay, because when people they don't have to walk for very far. Okay. Then planning guideline for escalator. These are the basic dimensions: floor to floor height, preferably like about 6 meter. If you are using there are two types. Normally 30 degrees or 35 degrees. Okay, two types of escalator, and then depends on the height. Okay, if it's 6 meter, then the length, if you are using 35 degrees, is 13.3. If 30 degrees, it's 15.1. Okay, so basically that's how you read the diagram. Okay, so these are the different components. I think later on this is the details. Right. So these are the components, so just for knowledge. But if you're using escalators, you would be able to see this triangle. Okay, so basically this is for safety purpose. Or sometimes the other places, but I've not seen this in Malaysia. Maybe in overseas, they have this kind of thing. Basically to alert people if, let's say, their hand is, let's say, jutting out from the escalator, right? If they don't move their hand, then probably it would actually get into this space between the two escalator, okay, and might break or something. Okay, that's for safety purpose. Okay, so another type of transportation is the stair lift. Okay, something like escalator but then just for disabled to sit, or maybe elderly people, they can sit here, and then the chair actually move next to the staircase. I think you can find this in the KLCC LRT station. The new one is this spiral escalator. I've not seen this before. Okay, I'm not sure whether there's such thing in Malaysia, but this is in Las Vegas, Caesars Palace in Las Vegas. So nowadays you can even have like a spiral escalator, which is nicer compared to the usual one, and save more space. Okay, moving walkway. I think everyone knows this, and I believe everyone has got onto one at least. Okay, intended for horizontal movement. It can be either flat or inclined up to 15 degrees. Right. The width is between 0.6 meter to 1 meter. Okay, usually used at air terminals, railway station, and shopping centers. Okay, basically to make people walk faster, right? So normally, if you use this moving walkway, you don't. Depends lah. If you're lazy to walk, then you just stand there, and then the moving walkway would carry you to the next point. But if you really want to be quick, right? You're moving fast, then you can also walk on top of the moving walkways, right, to arrive faster. Okay, guideline is something like this. If it's 10 degrees, and then the height is 4 meter, the height is 4 meter, then the length is 25.9. Okay, it uses more space lah, basically, right? It's longer. Other type of transportation is conveyor belt, right? Conveyor belt, basically the same concept as moving walkways, but generally to use to move goods, food, and so on. Okay. Examples of conveyor belt is baggage conveyor belts in airports, or conveyor belts in factories, and even in sushi restaurants. So you can see the conveyor belts, right, to move sushi. Okay. All right. So basically that's the end of my slide. Right. Any question before we proceed with the tutorial session? Okay, Mr. Rizal, over to you.
Okay, thank you, Mr. Adib.
Okay. I'm so sorry for the bad connection.
Okay. Now we are going to have a tutorial. So this